Okay, on to the next question. So use the above choices to answer the following questions. Which period contains the smallest atoms? Well, now we're talking about periods, right? So which one? Well, if this is period 1, 2, 3, and 4, well, I guess we have to draw out these periods now too, don't we? Okay, so you've got okay. This is going to be period 1, followed by period 2, okay, followed by period 4, which would be this guy right down here, followed by period 6, which is next to last down here. Okay. So, which period contains the smallest atoms? So we would look here and we would say, well, where are the smallest atoms on the periodic table? So the trend here is that they get smaller as you go up the periodic table. So it would have to be the highest period. So period 1. Okay, which period contains the most electronegative atoms? Well, electronegativity increases as you go to the right. Doesn't really help us a lot because these go all the way from left to the right. But what happens as you go up? Well, as you go up, you have less and less electron shells. So there's more and more exposure to the outside world, to the inner nuclear charge. So as you go up, the electronegativity increases. So again, that would be period 1. Which period has 4 electron shells? Well, 1, 2, 4. 4, of course. Every time you go down a period, you add an electron shell, so it would be 4. Which period only contains elements that do not follow the octet rule? Well, the octet rule states that atoms are in their happiest electron configuration if they have 8 electrons. What doesn't have 8 electrons? Well, boron doesn't follow, but that's only one element, and it's in this period here. Right about there is boron, but period 1 only has hydrogen and helium, and they only want 2 because the first electron shell can only hold 2 electrons. Only in first electron shell. So it would have to be 1. Let's flip over. Which period contains the most reactive non-metal? Most reactive non-metal. So the non-metals are where in the periodic table? They are over here on the opposite side of the stair step. So the most reactive is going to be the most electronegative in this case. So it would be helium, but helium has no electronegativity because it's a noble gas. All of the noble gases are very non-reactive. So the next thing that's the furthest up and furthest to the right would be fluorine. So it's fluorine, which is in period 2. Which period contains a noble gas with the atomic number 85? That's pretty... Should be 86 actually. 86, it should be right on. This, a noble gas, it should, or you could say, noble gas, you could say halogen, which is 85. That's what I get for putting this thing together while I was on the train. So I would accept, oh, wait a second, which contains a noble gas with the atomic number 85. If you said nothing, then I would accept that. But technically it's supposed to be period 6. Period 6 is what I was looking for there. Kudos to you if you caught my gaffe there. 17. Which diagram correctly shows the relationship between electronegativity and atomic number for the elements of period 5? Well, you'd have to look at a table of electronegativity, and you know, if you got what you would look, that's electronegativity, right? So what's happening in period 5? 1, 2, 3, 4, 5. Well, it's going up to 2.2, and then it goes down 1.9, 1.7, and then it goes back up again to 109, 2.1, 2.5. For period 3, it consistently goes up, 0.9, 1.2, 1.5, 1.8, 2.1, 2.53. It's consistently going up, right? So we're looking for something that is increasing as you go up an atomic number. But for us, for 5, sometimes it goes down. So we would take something like this. If we're talking about period 3, it would be more of something like that, okay? Because period 3 is consistently increasing across the period. That's what it means to have a periodic trend. And also, if you know that the relationship between electronegativity and atomic number, you know that it's a periodic trend, so you would know that it's increasing. Okay, that's 7 minutes. The bell just rang, so let's stop there, and we will continue on the next video.